welcome to this video where we're going to look at problem solving with geometry. So in the past video we looked at triangles, and we're going to look at a specific type of triangle, the right triangle, where we can apply something called the Pythagorean theorem. So essentially, when you have a right triangle, indicated by the square there, you have the side directly across from the right angle, which is called the hypotenuse. And the hypotenuse is the longest side of the right triangle. It's directly across from the right angle. The other two sides of the triangle are called the legs. And there's a special relationship between the legs of a right triangle and the hypotenuse. And the Pythagorean theorem tells us that if you square both of the legs and add them together, it's going to equal the hypotenuse squared. So think of it as leg squared plus leg squared equals hypotenuse squared. In place of the legs, we're going to call those A and B, and we'll call the hypotenuse C. So C always has to be the hypotenuse. A and B are interchangeable. And this only applies to right triangles. So if we're given two sides, any two sides of the right triangle, we can figure out the third side using the Pythagorean theorem. Let's look at a real life example. So here's a map showing several city streets in a rectangular grid. The lengths of the individual city blocks are 1/8 of a mile in the east-west direction and 1/16 of a mile in the north-south direction. How far is the library from the subway along the walking path shown? So here we have the library, here we have the subway. And what we want to do is we want to walk along the path that's shown there. So in other words, I would want to walk like this. Okay, so I know that each of these is 1/8 of a mile. How many of those would I need to walk to get to this point here, which is going to be directly across, right? In other words, if I was to add up all of these, what is the length? So I need to count. I've got 1, 2, 3, 4, 5, 6. So that means I have 6 times 1/8 of a mile. And I'm going to add that to the vertical distances that I'm going. So the vertical distances are 1/16 of a mile. And there's 1, 2, 3, 4, 5, 6, 7, 8 of those. So that's going to be 8 times 1/16 of a mile. So now if I multiply 6 times 1/8, I get 6/8. And 8 times 16, or 8 times 1 is 8/16. In order to add them, I need a common denominator. And I know that the common denominator of 8 and 16 is 16 because 8 divides into 16 and 16 divides into itself. So how many 8s go into 16? 2. So that means I need to multiply this top number, the numerator, by 2. 6 times 2 is 12. Okay, 12/16 is equivalent to 6/8. And then since this denominator is already 16, I don't need to change anything. It's just going to stay an 8. Now when I add those, 12 plus 8, I get 20/16, which reduces, so if I reduce that, 4 divides into 20 5 times, 4 divides into 16 4 times. So it's 5/4 of a mile, or 1 1/4 miles. Okay, and I know that because 5 divided by 4 is 1.25. So if I was to travel this distance here, the zigzag distance, I would travel 1 1/4 miles. What if I was to go in a straight diagonal path, though. Your book refers to that as the crow flies, right? So from directly from one point to the other in a straight line. So if that's the case now, let's think of this as a right triangle. Okay, so I know that this distance here we already calculated as 6/8 of a mile. And I know that this distance here we calculated as 8/16 of a mile. So I need to figure out this distance. That's my question mark. So since it's a right triangle, and I know that because it makes an L, so we have a 90-degree angle. Since it's a right triangle and I'm missing one side, I can use the Pythagorean theorem, which is a squared plus b squared equals c squared. The 6/8 mile and the 8/16 are my legs. So I'm going to have 6/8 miles squared plus 8/16 miles squared. And you can reduce those if you want, but I'm not going to bother because I'm going to change them to decimals here in a second. And I'm looking for c, which is the straight line distance from the library to the subway. So now let's convert 6/8 to a decimal and 8/16 to a decimal. I'm going to pull up Desmos. Okay, so we know that 6/8, 6 divided by 8 is 0.75. And 8 divided by 16 we know is a half, so it's 0.5. So we have 0.75 squared plus 0.5 squared. And of course, those are both in miles. Now, when you square 0.75 squared, you get 0.5625. And when I square 0.5, I get 0.25. So I'm going to have 0.5625 plus 0.25. Okay, now I can add those together. So when I add 0.5625 plus 0.25, I get 0.8125. And that's equal to c squared. Okay, now that's not what I want. I want to figure out c, which is the distance from the library to the subway. So I need to get rid of the squared. So to undo a square, I'm going to just take the square root. And the square root of 0.8125 is 0.9014. So about 0.90 or 0.9, which is 9/10 of a mile. So as you can see, if you were to walk in the zigzag direction, you would go 1¼ miles. If you go in a straight line path, it's shorter. It's 9/10 of a mile. So it's much shorter. You can pause the video at this point and then try the next problems, and you can unpause when you're ready to move on. And if you have any questions, you can feel free to reach out to me. In this problem, we need to find the area in acres of the triangular mountain lot shown. Now, if we look, we have a right triangle and we're missing one side. Okay, in order to find the area, if you'll recall, the area of a triangle is 1/2 the base times the height. Well, I have the base, but I'm missing the height. And the base and height will always be perpendicular to each other, so they're always going to form a right angle when they intersect. So I need to find this. Okay, now, what am I given? If I have a right triangle and I'm missing one side, I can use the Pythagorean theorem to figure out the missing side. However, in this problem, if If I go across from my right angle, I'm given C. I have A, and I'm missing B, okay? So my A is going to be 250, and I'm going to square that, plus I don't know B, so we'll have B squared, equals 1200 squared. Okay, now I need to solve for B squared, so I'm going to move some things around. I'm going to subtract this 250 squared, and I'm going to have B squared equals 1200 squared minus 250 squared. And if you recall from the last problem, if I want to undo a square, I have to take the square root. So now I'll be left with just the height, which is B. So I'm just going to type this in, the square root of 1200 squared minus 250 squared. And I end up with 1173.6, etc. So we'll make that about 1174. Okay, so it's approximately 1174. And of course it's feet, right? So I just found the height now. So in order to find the area, I have everything I need. My area is going to be 1/2 times the base times the height. And remember, instead of 1/2, you could just put 0.5. So we can do 0.5 times 250 times 1174, and we get roughly 146,750 feet squared, right? Because we're dealing with area. Now, the problem asks us to find the area in acres. So you'll need to recall what the relationship is between square feet and acres. And if you look back at the conversions, and if you don't remember, you can just look it up. We know that in 1 acre, there's 43,560 square feet, okay? So what I'm going to do right now is I'm going to take the 146,750 feet squared, and I'm going to multiply by 1 acre over 43,560 feet squared. My feet squareds are going to go away, and really all I have is 146,750 divided by 43,560. So we've got 146,750 and then divided by 43,560. And you end up with about 3.4 acres if we round to the nearest tenth. So that's how many acres would be the triangular mountain lot that's shown. Let's talk about similar triangles. Like, what does similar mean? If things are similar. In geometry, it means they have the same shape, but not necessarily the same size. Okay. What we know is corresponding pairs of angles in the triangles, since that's what we're working with, are going to be equal. In geometry, we would say congruent. And the ratio of the corresponding side lengths are going to be equal. Okay, In other words, the corresponding sides will be proportional. So that's another way you can look at it. Remember, just proportions are just equal fractions. So what we're looking at here is if I had, let's say, two triangles. So here's one triangle. Okay, and then I'm going to duplicate that. Okay, if I was to take this, actually it's not going to let me. Let me start over. Okay. There we go. Okay, now I'll duplicate this. Right, you can see, right, that the angles are equal and the sides are proportional. Okay, these two triangles are congruent, they're equal, but congruent triangles are also similar. Now, if I change the size and I slide it over, you can see how the corresponding angles are still equal. That the top angles equal each other, the left bottom ones equal each other, and the right bottom ones equal each other. Okay, these are similar, same shape, different size. The side lengths are, corresponding side lengths are proportional, which means the ratios of the corresponding side lengths are equal. So if I was to call this like A, B, and C, and then this angle, I call it A with an apostrophe, we call it A prime, B prime, and C prime, then I know that A over A prime is going to be the same thing as B over B prime, which is the same thing as C over C prime. So in other words, let's say I had 10, 8, and 6, okay, and they could be whatever units, feet, inches, whatever. Let's say I make this 5, 4, and 3. If I was to take the corresponding side lengths, so like this side corresponds to this one, and this side corresponds to this one, and then the remaining sides correspond. If I was to divide the side lengths now, so let's call this like 10 over 5, that's going to be the same thing as 8 over 4, which is the same thing as 6 over 3. Okay, and I want to change this too, so it makes more sense according to my drawing for you all. So A, we'll call it AB, is going to be the same thing as A prime, B prime, and BC would be the same as B prime, C prime, and CA is going to be the same thing as C prime, A prime. Okay, so here's an example. We've got two triangles that are similar, and we want to find the lengths of the sides labeled A and C prime. So what I need to do is I need to first figure out the corresponding sides and match up two that correspond, where there's actually numbers. And what I notice here is that B and B prime, side B is 9 units and side B prime is 6 units. So I know that if I do B over B prime, it's going to give me the same answer. It's going to tell me what the unknown side length is for C prime, right? So that's going to be the same as C over C prime. So their ratios of their corresponding side lengths are going to be equal. And like I said earlier, another way to look at that is just that the corresponding sides are proportional. Okay, so I'm going to take side B, which is 9, and B prime corresponds to it, that's 6. And then I've got C, which is 12, over C prime. Okay, and I'm trying to find C prime. So one way I could do this, when you have a proportion, which are two equal fractions, you can just cross multiply and then divide. It's a quick way to do it. So you get 9 times c prime equals 6 times 12. And I know 6 times 12 is 72. So you get 9 c prime equals 72. And then if I want to solve for c prime, so let me shrink this. 9 times what number gives me 72? Well, you can use some mental math there. You'll get 8. But let's just divide. So 72 divided by 9 gives us 8. Okay, so I know that this is now 8. Okay, now why is that important? Well, 9/6 reduces to the same fraction that 12/8 does, right? So 9/6 is basically 3 over 2. And if you reduce 12/8, you also get 3 over 2, okay? Or 1.5. So I know that like this side is 1.5 times bigger than that side. So if I multiply 8 by 1.5, I'll get 12. If I multiply 6 times 1.5, I get 9. So I could just do 4 times 1.5 and I could get A, right? So to figure out A, I could just do 4 times 1.5, which is 6, or I can set it up like this again. I can do b over b prime equals a over a prime. And again, you could just get 9/6. And this time you're looking for a, and I know that a corresponds to 4. So I would have 6 times a equals 9 times 4. So you get 6a equals 36, and 6 times what number equals 36? It's just 6. So a is 6. The rest of the problems I'm going to have you try on your own, except for the last one. We'll do this one together so that you can get a visual and then try solving it. Okay, I'll give you a second to read the problem, so feel free to pause and then unpause when you're ready. Some cities have policies that prevent owners from constructing new houses or additions that cast shadows on neighboring houses. The intent of these policies is to allow everyone access to the sun for powering solar energy devices. Consider the following solar access policy. On the shortest day of the year, a house cannot cast a noontime shadow that reaches farther than the shadow that would be cast by a 12-foot fence on the property line. Find the maximum allowed height for a house with a 12-foot fence on the property line that casts a 20-foot shadow on the shortest day of the year, and the north side of the house is set back 30 feet from the property line. So let's get a visual here. So first of all, we got our house. Okay, put some windows. There's our house, and we have the sun, of course. Okay, and let's draw what it's telling us here. So we know we have a 12-foot fence. We know that the fence casts a 20-foot shadow, okay? And the north side of the house is set back 30 feet from the property line. So I know that right here, from here to like maybe let's say here, is 30 feet. And then that's where my fence is going to go. And I know my fence is what, 12 feet. And the fence casts a shadow that's 20 feet. So now if I look at this, what I have is basically two right triangles. Okay, the first triangle is the smaller one that's 12 feet and 20 feet. And then I have the bigger one, okay, which is this one right here, which I know is 50 feet at the bottom, and I don't know the height. That's what I'm looking for. So I'm trying to figure out h. Well, I have two similar triangles, so I can set up a proportion. So I just need to match up the corresponding sides, right? So I know that the 12 corresponds to the h, so maybe I'll do like 12 divided by h. And then in the for the other fraction, since I started over here and put the 12 in the numerator, I need to put the 20 in the numerator. and put it over 50. So I'm going to have 20 over 50. Okay, and then I'm going to have you try solving that on your own, based off of what we just did earlier in the video. But I will tell you that the answer should come out to be 30 feet. So try solving that and make sure you get 30 feet for your answer. But that wraps up this chapter, this unit on geometry. If you have any questions with this section, please reach out. Have a great day.